Okay, so uh, I think that I forgot in the last video application activity 112. I forgot to also answer question number 2. So before we move to operations on matrices, so I should do also answer this question. So question number 2 was not answered as far as I can remember. So I stopped it. I worked A here until here. So also B, it was worked out yesterday in video number 5. So I think that now we can consider application activity number 2. So we have matrix x and y. Suppose we have x. Before I move to operations on matrices, so I should first consider exercise number 2 in this activity, and the question is, we have two matrices, matrix X, matrix Y, and then if they are equal, this is question number 2. Question number 2 here. Okay, so number 2, if x is equal to y, so in this case, matrix X is this one, 2x squared minus x, 0, 1 over 3, z, and here we have 1, we have y, and t squared plus t, so minus 5. So this means that we have x first coefficient minus 2x squared minus x. So first row, first column, second row, first column, we have 0. So second column, we have a third, 1 over 3, and z here. So that is the matrix X here. So matrix Y. So we have first column 1 t squared plus t, and then y and negative 5. Now, if these two matrices are equal, in this case, this coefficient must be the same as this, 2x squared minus x equal to 1, and this coefficient must be equal to that. So we have, let us write y is equal to 1 over 3, and s is 1 over 3, and then, so we have this coefficient is equal to this coefficient z is equal to negative 5, and finally this coefficient and that must also be equal to t squared plus t must be equal to 0. So we have to solve this system, and this system is not a linear system because you have a quadratic equation here. This system is not a linear system, not linear. It is not linear because of this quadratic polynomials. But already we are required to find what the value of x, what is the value of y, the value of z, and the value of t. Okay, so clearly here it is clear that the value of y x, so we have to determine this from the first equation. So here value of y is 1/3, value of z is clearly -5. Now we are concerned with the value of x and the value of t. So apart from these two values, so we need to solve the first equation and the second one. This equation can also be written as 2x squared minus x minus 1 is equal to 0. The second one, I can factor out t, so that I'm left with t times t plus 1. So already here, so we have to solve. So we can factor out the 2, and we have 2 times x squared minus 1/2 times x minus half, so equal to 0. So then here we have t equal to 0 or so t plus 1 equal to 0. So in this case, we have so here in the first equation here, so we must have two numbers such that sum is half and product is negative 1/2. So x must be equal to half of the sum negative, which is equal to half. So plus or negative half of square root. So x no, a half power 2, the sum minus 4 times product, which is -1/2. So this is from the formula of for quadratic function like this. So x is equal to half sum of the two roots, because it is quadratic, it should have two roots, plus or negative half of square root of sum power 2 minus 4 times product of root. Now here product of roots is -1/2. So here we have this is -1/2. In this case, is -1/2. So coming from this identity, so this represents the sum, and this number represents product of roots for this polynomial, or solution for this first equation. Now, our calculation will bring x equal to 1/4 plus or negative half of square root 1/4 plus now 4/2 is just 2, so common denominator will be 8/2 over 4. Sorry, so because if I simplify, I'm gonna get plus 2. 4 divided by 2 is 2, so same as 8/4. So now in this case, the value of x, so the value of x here. Okay, let me put the value of x here. Value of x is equal to a quarter, also negative half of square root of 9 over 4. Now I have a quarter, 9 quarters. I can factor out and get a quarter plus or negative 3 halves, 3 over 2. So this means that x is equal to, no, it is times half. So this will be 1 over 4, a quarter plus or negative 3 quarters. Okay, in that case, you have a quarter plus 3 over 4, or x is equal to a quarter minus 3 over 4. So this is equal to 1 because it's going to be 4 over 4, x is equal 1, or now x is equal, now here we have a negative 2 over 4, which is equal to negative a half. So it is clear that the sum of these two solutions is going to be equal to a half, because 1 minus half is a half, which is the sum of roots. If I add them, I'm gonna get a half. So the product 1 times negative half is going to be negative a half as the product, as you have indicated here. Okay, so finally we have two values of x. Now how about the values of t? So values of t, it is clear. In this case, t is equal either to 0 or t equal to negative 1. And let us continue over here. So we remember that the value of y is 1/3. Value of z is negative 5. Now the values of y is equal to, we remember it is 1/3, and the values of